Hi, grade 12s. Now, this finally is the goal of this whole chapter. So if you've watched all the couple of videos that I posted previously on the polynomial division, and if you watched the one on the factor theorem and the remainder theorem, this is where we're trying to get to. We are trying to solve third-degree equations of this particular format. So if you've gone through the other videos and you've looked at it and you didn't necessarily participate too much and you didn't really understand exactly what was going on, this is pretty much what I need you to take away from this chapter, because this is what's going to be assessed. So at the end of this video, I'll discuss exactly what is important in this particular chapter and what you need to carry forward into the next section. Okay, so please remember, this is the goal of the whole chapter. This is the part you need to get. And the good news about this part is you can actually go and do this entire section by using the calculator. So yes, especially if you hate your algebra, the calculator will get you out of trouble in this case. But that being said, it's got to be the Silver calculator. So when I want to solve an equation like the following, and this is the example 1 on page 181. Solve x cubed plus 8x squared plus 17x plus 10 is equal to 0. Then what we've got here is we've got a cubic expression, which is exactly the ones we factorized in the previous video. So in order to do this one, I will first need to get one factor. So to get that one factor, I'm again going to use the same technique that I did for the factorization, and I'm going to say set that polynomial equal to fx, which is x cubed plus 8x squared plus 17x plus 10. Now I need to go and I need to find one factor in order to factorize the rest. And to find that one factor, I'm again going to go and use my table function because it just makes things so much easier to do. So I'll go mode table function and I will type in that polynomial. So it's the x cubed plus the 8x squared plus the 17x plus 10. And then I'll just skip gx. This one I will start at -5, I'll end at 5 just to get a slightly wider spread of values. I press equal, I step in ones, and I scroll down. Now the first time I encounter that 0, right there, that tells me that I have found a factor. Now again, careful, I did mention this in the previous video. We now know that the f of -5 is equal to 0, so I'm going to write that down. So the f of -5 is equal to 0. Therefore, my deduction, and careful, we did say that if -5 gives me 0, then that -5 is a root. But the factor then is x plus 5. So therefore, x plus 5 is a factor. Great. So now that I know x plus 5 is a factor, I can use that factor with that lovely little inspection method, or if you still don't prefer the inspection method, you could use long division, but I'm going to use the inspection method, and I'm going to say that then means that x cubed plus 8x squared plus 17x plus 10 is equal to 0. Now x plus 5 is a factor, so I'm going to say it's x plus 5 times, and this will have to be my quadratic trinomial. And just to explain again, we're going to say the first term times the first term here has got to be equal to that x cubed. So this has got to be x squared. And I've got to say the last term times the last term there has got to be equal to that 10. So this has got to be equal to plus 2. Now again, our little problem lies with the fact we know there's got to be an x there, because that's how the degree of that trinomial works. It goes x squared, then x, then a constant. But I have no idea what this coefficient is supposed to be. What I do know is if I multiply those two terms by each other, I get 5x squared. I want to multiply these two terms by each other because that will also give me a result of x squared. Don't know what that is at the moment because I'm missing a coefficient. But if I add these two together, that's got to give me the 8x squared over here. So the 5x squared plus whatever has got to give me the 8x squared. And then I just work backwards and I say, what plus 5x squared is 8x squared? 3x squared. And then I say, x times what gives me 3x squared? X times positive 3x. Which means I now have the quadratic trinomial over there, where if I multiply the binomial by the quadratic trinomial, it will give me this expression. And I can finish that up saying it's therefore x plus 5, and I'm going to factorize that trinomial, and that's going to give me x times x, 2 times 1, and in this case it's got to be plus 2 and plus 1. So now I can get my answers, or my roots. My roots are x equal to negative 5, or x equal to negative 2, or x equal to negative 1. Now, even if you don't have a silver calculator, you guys saw that in order to find this factor, x plus 5, I used the table function on the calculator. Now, when I use the table function on the calculator, you have to remember that your normal black or the blue or even the pink calculator also has this table function. Now, I just want to show you something. We said x plus 5 is a factor because we got that 0. But if I scroll further down, there are more zeros to be found. The next 0 I find there from negative 2. And now I want you to look at the answer I've got down here. Negative 2 was one of my answers, and x plus 2 was one of my factors. So even if I don't use, and I'll show you just now how to use the equation mode on the calculator to find this, even though I don't have an equation mode because I don't have the silver calculator, this table mode could actually go and find me all 3 of the answers. So if I scroll down even more, look at that. I've got another 0, and I got that 0 from getting negative 1. So just by using the table mode and spotting the zeros, which means you have to understand the factor theorem, I managed to get all 3 of the answers for this cubic equation. I got the negative 5, I've got the negative 2, I've got the negative 1 by spotting the zeros. So did you really have to go through all of that? No. You could have just typed this into the calculator and then found the zeros. Now, unfortunately, this won't work if these answers are like halves or quarters because I stepped in ones. But luckily, in the next example, when we use the equation mode, you'll see the equation mode solves everything for you, no problem. So let's look at the next example, which is pretty much this one, but using the calculator. So please remember, it's got to be the silver calculator, the Casio FX991ZA+. Now, first things first, we have to change the mode. So you have to make sure you change your mode onto equation mode. So mode, and then I select 5, which is my equation mode. And then I select 4, and 4 shows me this ax cubed plus bx squared plus cx plus d, which is the standard format of a cubic equation. So I'm going to select 4. Now, when you select 4, it asks you for an a value, a b value, a c value, and if I scroll over, it also asks you for a d value. That is because in this case, a is the coefficient of x cubed, which is 1, b is the coefficient of x squared, which is 8, c is the coefficient of x, which is 17, and d is the coefficient, or not the coefficient, it's the constant value, in this case it's 10. So now that I've got my values, I can just go back on my calculator saying my a value is 1, so I enter 1, and I press equal. My b value is 8, my c value is 17, and my d value is 10. And then the beauty of this calculator, when you press equal, it tells you the first root, x1, is negative 5, which you already know from doing it the long way around, that is the correct answer. Or, press equal again, the other option, x is equal to negative 1. Or, the last option, x is equal to negative 2. So those are my 1, 2, 3 roots. Simply typing it into the calculator. And yes, people, for tests and for exams, you are totally allowed to use this method to find those 3 roots. So if you've watched all of these videos and you've come to this point and you go like, oh, really? I did all of that other work and I can just do it on the calculator? Yes, people, you can just do it on the calculator. Unfortunately, it won't work for the NBTs, but for your final exam, if you have a silver calculator, this will no problem solve your cubic equations for you. Right, so let's do another example, simply using the calculator. So in this case, please watch out because they've now thrown the order around. This is not in descending order of powers, this is an ascending order of powers. So I'm going to have to first write it in standard form, which in this case is minus x cubed plus 5x plus 2 is equal to 0. Now when I write down that a, b, c, and d value, just watch out please people, because a is the coefficient of x cubed, so that's negative 1. b is the coefficient of, careful, x squared. So because b is the coefficient of x squared, you have to notice there is no x squared here. And that is why the b value is 0. C is the coefficient of x, which in this case is 5. And d is my constant value, which in this case is 2. So I've got my a, my b, my c, and my d value. And then I can bring back the calculator. And I can say, for this particular equation, a is -1. B is equal to 0. C is equal to 5. And d is equal to 2. Which x is equal to 2, 4, correct to 1 decimal place, or x is equal to -0, 4, or x is equal to -2. And you'll notice that this one, the calculator was lovely because I've got those 2 irrational roots that I rounded off to 1 decimal place. So using the silver calculator really is simple, straightforward, very easy to do. So especially for tests and exams, I have to say use the silver calculator if you've got it. Because the black or the blue or the pink calculator, yes, it would have found that one for you, but there's no way it would have found those roots for you because they are irrational roots. Right, so another example. Again, using the calculator, very easy, simple, and straightforward. My a value is equal to 1. My b value is equal to 1. My c value is equal to -10. And my d value is equal to 8. So I can again go and I can say, type that in. A is 1, b is 1, c is -10, and d is 8. Which then means x is equal to -4, or x is equal to 2, or x is equal to 1. So there are my 3 answers. Now, for this one particularly, if you don't have the silver calculator, the black, pink, or blue calculator will help you if you use the table function. So just to remind you again of how the table function will find these answers for you, you select mode and then you go to your table mode. You type in this polynomial under fx, so that will be the x cubed plus x squared minus 10x plus 8. There we go. And then I leave this one blank, and then I go and I start at -5. That's just to cast a slightly wider net to try and get more possibilities for my answers. I end at 5 and I step in 1. And then again, remember what we're working with here is the factor theorem. The factor theorem says any value here that gives me 0 is a factor. So x plus 4 is the factor, but x minus 4 is my root. So if I go down, that 0 tells me -4 is one of the roots, so it's one of my solutions. If I scroll further down, then over there I get another 0 at 1, which yes, that's one of my solutions, that's one of my answers. And if I scroll further down, I get another answer here, which x equal to 2 gives me 0, so x is equal to 2. So those are my 3 answers, which is a much easier example than the previous one because all 3 of these answers are rational, so that's why I picked them up on the table function. So yes, if you don't have a silver calculator, you can actually use the table function and your understanding of the factor theorem just to find those 3 factors, which will give you the solutions. Right. What do I need to know after all of this? So pretty much from the start of the chapter on polynomials, the whole goal with this chapter was for you to be able to factorize cubic polynomials. Why? You need to be able to factorize the cubic polynomials in order to solve the cubic equations. That right there is incredibly important for differential calculus, which is the next chapter. So when we start the next video, we're starting differential calculus, and I cannot stress enough on how important this differential calculus is. You have to make sure you understand every last little thing because it is very, very, very important for your final examination. So why are we solving these cubic equations in differential calculus? Because later on in differential calculus, we are going to be drawing graphs in this form, which is called a cubic graph because it's got that x to the power 3. So these cubic graphs, not that you have to know it now, we will get to it later in great detail, but these cubic graphs normally look like this. So they normally look something like that. And if you notice, when they cut this x-axis, they cut the x-axis in 1, 2, 3 places, which means I have 1, 2, 3 answers, which is exactly what I get whenever I solve that cubic equation. So it's used when finding the x-intercepts of graphs in that format. So when we are going to draw these graphs later on in the chapter on differential calculus, we need to be able to solve these cubic equations. Now, there's one last little interesting part that is useful. The polynomial division is useful for one specific thing, converting between different forms of a hyperbola equation. Now, this they don't ask often, but they have asked it in matric exams. So I am just going to cover this with you just in case. So if you look at the hyperbola, the standard form of a hyperbola equation reads fx is equal to a over x minus p plus q. And I know the asymptote of this graph is where x minus p is 0, in other words, x is equal to p, and it's where y is equal to q. That's my vertical and my horizontal asymptote. So if it's written like this, I can easily go and say, oh, okay, my asymptote is where x plus 3 is equal to 0, so x equal to negative 3, and my horizontal asymptote is where y is equal to negative 1, and I'm done. But sometimes what they do is they say, this is a hyperbola equation. Please now go and find the asymptotes for that particular one. Now, most of you will look at that and go like, that's not a hyperbola. Hyperbola looks like this. It doesn't look like that. But what has happened over here is they have gone and they've simplified the equation by putting it over an LCM of the denominator. And because they simplified the equation, and it's not necessarily the same equation, but because they've simplified the equation by putting it over the LCM of the denominator, it ends up looking like this. Now, if it ends up looking like this, good news about finding these asymptotes. The vertical asymptote is still exactly the same way. So my vertical asymptote, I'm again just going to look at the denominator, set that equal to 0, which means x is equal to 2, and then I know for a fact that is my vertical asymptote. But the problem is I don't know what my horizontal asymptote is. And in order to find the horizontal asymptote, I can quickly go and do that algebraic manipulation that I showed you. So the algebraic manipulation, if you recall, for polynomial division, says I have the x minus 2 at the bottom, so I need the x minus 2 at the top. But here, this value that I'm going to put in there times the first term, it's got to be equal to the 5x. So I've got to put 5 there, so that 5 times x gives me 5x. But now, 5 times negative 2 is not negative 13. 5 times negative 2 is negative 10. So in order to get back to that negative 13, I need to put minus 3 over there. Now, luckily, this is very nice, short and sweet, because we are pretty much done. We're going to say, if I divide that term by the x minus 2, the x minus 2 divides into the x minus 2, so I have 5 over there. And then over there, I just have the minus 3 left over the x minus 2. And then if I just rearrange the terms, then it looks exactly the way it's supposed to look, the way we recognize it. And now we can say, okay, so that can be rewritten as this, which means I'm quite aware that my vertical asymptote is x is equal to 2, but now I'm also aware that my horizontal asymptote is going to be where y is equal to 5. So yes, this polynomial division can actually now be used to convert that format of a hyperbola equation into this format, which makes it much, much, much easier to get that horizontal asymptote. By the way, just for interest's sake, there's a lovely little deduction you can see from this, I hope, which is, technically speaking, right there, this. Do you notice? Right there is actually my horizontal asymptote. So do you really need to do all of this? No, probably not. Whatever the coefficient of x is up top over here, that is going to be my horizontal asymptote. So thank you very much for watching. Next video, very, very important. That's going to be our introduction into differential calculus. So yes, this chapter, it was a little bit up, a little bit down, but we had to do this background information for you to understand the work in the next chapter. So thank you very much for listening.